Question 9 from Unit 2 higher paper or question 19 from the intermediate paper. We're going to be doing some trigonometry on this question, so it's important your calculator is in the right mode. So at the top of your screen there is a little D, or should be. If you don't have this little D, the way you fix that and get it into the right mode is you follow this sequence. So you're going to press Shift, then Menu, and then 2, and then 1. So 2 will bring up this angle unit choice, which allows you to select 1 for degrees, 2 for radians, and 3 for gradians. Now this is a bit like just different units for angle, so a bit like centimeters or inches. We need to be in degrees, so you select 1 for degrees and make sure you put that little D at the top of your screen. So to warm up then, we're just going to recap some of the basics of trigonometry. We're going to look at 3 examples, and we're just going to outline a little procedure that if we follow it for all of these questions, we should be fine. Any trig questions, we should be fine doing this. So I've got 3 ratios. Sine of an angle equals opposite over hypotenuse, cos of the angle equals adjacent over hypotenuse, and tan of the angle opposite over adjacent. The first thing I need to do is label which sides are involved in my triangle. I've got my hypotenuse, and so I shade that in my formulas just to help me choose. And this side is adjacent to the angle, so I also shade that in. Remember, your hypotenuse is the one that is the longest side in your right angle triangle. Okay, and your adjacent is not the hypotenuse but next to the angle. Now I've shaded those into my formulae, I can see the only ratio that I'm interested in is the cosine or cos. You can take cosine if you like. Cos theta, or cos of the angle, equals the adjacent over hypotenuse. So the first thing I do is I state which formula I'm going to use. Making that choice is really important. And then I'm just going to substitute in what I know. So my adjacent I know is 10.4, and my hypotenuse is 16.5. Then I need to get my angle out, which is called x. So I've put x in there. So the angle always belongs to that trigonometric function in there. To get rid of cos from both sides, instead of, if I had to get rid of adding 4, I'd take away 4. To get rid of squaring, I would square it. To get rid of cos, or to the opposite or inverse operation of cos, is cos to the minus 1. And to get that on your calculator, you need to press Shift cos. And in the bracket, you need 10.4 divided by 16.5. Should look something like this. And you get an answer of 50.9 degrees. That's one way through with a trigonometric formula where you need to find the angle. Let's have a look at a second example. This time again we've got 2 sides and an angle. You're always going to have in a trigonometric question in a right angle triangle, you're going to have something to do with 2 sides and the angle. Whether you're finding one of those 2 sides or you're finding the angle, always 2 sides involved, and they're the only 2 I ever label. So the 10 kilometre in this side is the opposite, the x kilometres, which we obviously need to find, is the adjacent. So I'll just colour those in the formulas, and I can see I need to use tan theta equals opposite over adjacent. So write that one down so the examiner knows what I'm doing, and pop in what I know. My angle is 23, so that's going to go in for theta. My opposite is 10, and I'm going to have an x underneath that fraction. So I've done most of the hard work. Now I've just got to get x on its own. So instead of dividing by x, I'm going to apply the opposite operation. So I'm going to times both sides by x to give me x tan 23. Now to get rid of tan 23, I'm going to divide by tan 23 all in one go. So I've got 10 divided by tan 23. Or it might look like that on your calculator, or you can put it in as a fraction. So x comes out to 1 decimal place to be 23.6 kilometres. If I have a look at this last example, exactly the same procedure again, but I've got, this time I've got my opposite side and my hypotenuse on what I'm working with. And I've shaded them in, and I can see I need to use the sine ratio. My angle is 17, and the hypotenuse is 31, and x is the opposite that I need to find. So I'll pop those in. And to get x on its own, I need to times both sides by 31. So I know that x is equal to 31 sine 17, which gives me 9.1 millimeters. So that should just be a bit of a recap of the basics of the steps when you're doing a trigonometric question. A right angle triangle. Label the two sides, pick the formula, then just rearrange those formula to get your answers out. So moving on to the exam question. We've got two triangles, ABC and CDE, and they've kind of been overlaid together. We've got all the dimensions written down as well as being put on the diagram. The diagram is not to scale, so we can't just measure off with a protractor. So what thinking do we need to do on this question? Well, we've got two right angle triangles, so I hope you can kind of see you've got this red one where you've got the 6.5, the 10.4 at the angle X, that's the ABC, and we've also got this green one with the 9.4 and the X and the 22 forming this top angle. So if I was to pull them out, there's my red one and there's my green one. So when we think about right angle triangles, two things should always spring to mind. Pythagoras and his theorem, and the trigonometric ratios are sine, cos and tan. And we need to just have those stored right at the front of our brain so we can use them whenever we need to. So let's see, bearing all these things in mind, how far we can get with this question. So part A, calculate the value of x, 3 marks. So x I can see was in that first red triangle that we talked about a second ago. So I've drawn out this triangle, and I would do this in my exam. I would draw out the triangle and start to label up my sides. I know I'm doing trigonometry. How do we know we're doing trigonometry? Because we're working with an angle in here. Not this right angle, but I've got another angle that I'm dealing with. So I know I'm going to have to use one of these three trig ratios. So just as we did before, I'm going to label my sides. I've got the opposite, I shade that in my formula. I've got my adjacent, and I shade those in my formula. So I can see I'm going to be using the tan ratio. So tan, and I've put in the x ready, because my angle is called x, equals the opposite over adjacent. And now I'll put my numbers in. Tan of x equals 6.5 divided by 10.4. And to get rid of tan, remember, to get rid of or to apply the opposite operation to tan is to do inverse tan, and you need to use the shift tan button on your calculator. And it might look like something like that when you type it in, and it gives us an answer of 32 degrees. That's a reasonable answer for an angle in a triangle. I have rounded this to the nearest whole number, because even if I go to one decimal place, I still don't need to worry. So I'm just going to do it to the nearest whole number. So that's part A done. It's important you identify the correct formula, and then you can solve that equation. Let's have a look at part B. Part B, we're asked to find the length of DE. So DE is this green side down here. So to make life a bit more simple, I am going to just draw out the green triangle on its own. I've got an angle of 32 now here rather than x, and I'm going to have to use that. That was the hence word. Hence, kind of big clue. Use what you've got to help you. So 32 and 22 in there means that top angle now is 54. So I've got an angle. I'm interested in the length of DE, so that's the other side that I'm interested in. So if I label up my sides, that one is the opposite, and the 9.4 is my hypotenuse, because it's the longest side of my triangle. So if I've got the opposite and the hypotenuse shaded in my formula, I can see that I'm using the sine ratio. So I'll just write that out, and now I can put my numbers in. My angle is 54, and my hypotenuse is 9.4. Times both sides by 9.4 to get DE on its own. So my answer, I need to pop into the calculator, 9.4 sine 54 looks something like this, and I can see that DE is 7.6 centimetres. That has been rounded to one decimal place. So I hope that helps with that trig question. Do remember your formula. You are not going to get given them, so make sure you're happy with remembering those ratios. And of course, Pythagoras' theorem, you should remember that too.